Welcome to our discussion on CD38 overactivation, nicotinamide adenine dinucleotide depletion, and mitochondrial dysfunction. We will explore their roles in immunological failure among virologically suppressed human immunodeficiency virus patients. Please take into account that the journal does not exist anymore. I will post the article on LinkedIn for free access. Despite antiretroviral therapy transforming human immunodeficiency virus into a manageable condition, about 30% of patients experience immunological failure. These immunological non-responders maintain cluster of differentiation 4 positive T-cell counts below 350 cells per microliter after 2 years of antiretroviral therapy, facing higher morbidity and mortality. The underlying causes of this failure remain elusive, necessitating further investigation. Take a moment to check this table of contributors to immunological failure. Cluster of differentiation 38 is a type 2 transmembrane glycoprotein found on various immune cells. It influences cell adhesion and migration by binding to cluster of differentiation 31. Cluster of differentiation 38's nicotinamide adenine dinucleotide glycohydrolase activity depletes nicotinamide adenine dinucleotide stores, crucial in immunological failure. It also catalyzes cyclic adenosine diphosphate ribose formation, affecting calcium channels and apoptosis. Additionally, cluster of differentiation 38 modulates immune responses, driving cytokine production and chronic inflammation in human immunodeficiency virus. Cluster of differentiation 38 overactivation is a key predictor of human immunodeficiency virus progression alongside human leukocyte antigen DR. It triggers immune destruction, enhancing cluster of differentiation 4 plus T-cell activation and creating new human immunodeficiency virus targets. This leads to further T-cell activation, immune exhaustion, and apoptosis. Antiretroviral therapy reduces cluster of differentiation 38 plus, cluster of differentiation 8 plus ratios, highlighting the importance of early antiretroviral therapy initiation to prevent irreversible damage. Take a moment to see the diverse and complex functions of the CD38 receptor. It took me forever to make this graphic. Nicotinamide adenine dinucleotide, NAD+, is vital for cellular life, cycling between NAD+ and NADH to support energy metabolism, DNA repair, cell signaling, and sirtuin activation. Its depletion disrupts adenosine triphosphate production, accelerates DNA damage, and impairs cellular communication. In people living with human immunodeficiency virus, CD38 overactivation exacerbates NAD+ decline, accelerating biological aging. Mitochondrial dysfunction in human immunodeficiency virus, termed human immunodeficiency virus-associated mitochondrial dysfunction, HIVAMD, results from impaired adenosine triphosphate generation via oxidative phosphorylation. Key targets include the electron transport chain, mitochondrial deoxyribonucleic acid, and mitochondrial membranes. Nicotinamide adenine dinucleotide depletion stalls the electron transport chain. Mitochondrial deoxyribonucleic acid mutations disrupt protein synthesis, and reactive oxygen species damage collapses membrane potential, triggering apoptosis. The central hypothesis links CD38 overactivation to human immunodeficiency virus-associated mitochondrial dysfunction, HIVAMD, through nicotinamide adenine dinucleotide depletion. This cascade leads to CD4 plus T-cell apoptosis, immune exhaustion, and mitochondrial dysfunction. The metabolic shift to aerobic glycolysis is pro-inflammatory and inefficient. CD38 inhibition increases nicotinamide adenine dinucleotide levels, highlighting its potential as a therapeutic target. Indoleamine 2,3-dioxygenase 1, or indoleamine 2,3-dioxygenase 1, is pivotal in human immunodeficiency virus pathogenesis. It diverts tryptophan from nicotinamide adenine dinucleotide synthesis, activated by human immunodeficiency virus stimuli like lipopolysaccharide and tumor necrosis factor alpha. This leads to toxic metabolites damaging mitochondria, contributing to CD4 T-cell depletion and immune imbalance, promoting regulatory T-cell conversion and suppressing antiviral immunity. Look at the graphic that I have done. Yes, maybe I am crazy. Who would spend so much time doing this? Only a lone wolf researcher. Two pathways explain the link between CD38 and indoleamine 2,3 dioxygenase 1 activation. The metabolic pathway involves nicotinamide adenine dinucleotide depletion, leading to toxic metabolite production and cluster of differentiation 4 apoptosis. The inflammatory pathway involves cytokine production, particularly tumor necrosis factor alpha, activating indoleamine 2,3 dioxygenase 1 and causing similar outcomes. Both pathways likely operate together, forming a feedback loop resistant to antiretroviral therapy. Microbial translocation from the gut due to human immunodeficiency virus-induced mucosal barrier disruption amplifies indoleamine 2,3 dioxygenase 1 activity through systemic lipopolysaccharide exposure. This creates a feedback loop sustaining chronic immune activation, leading to persistent immunometabolic failure and accelerated cellular aging. Even with virologic suppression, antiretroviral therapy alone cannot interrupt this self-sustaining cascade. This graphic is the integrated hypothesis. Please pause the video and take a look. Nicotinamide adenine dinucleotide levels decline naturally with age, but in people living with HIV, this is accelerated by chronic cluster of differentiation 38 overactivation. This leads to premature biological aging and frailty. The decline impairs sirtuin activity, worsening mitochondrial function, and contributing to age-related diseases like metabolic disorders and cardiovascular disease, occurring at a younger biological age in people living with HIV. I think the natural decline of NAD+ with aging is accelerated during chronic HIV infection. Hence, we can see aging-related diseases earlier than HIV-negative control subjects. Elite controllers naturally suppress human immunodeficiency virus without antiretroviral therapy, thanks to a unique CD38- HLA-DR+, CD8+ T-cell phenotype. This phenotype minimizes immune activation and systemic inflammation, preserving mitochondrial function. Therapeutically, targeting the CD38+, CD8+ ratio and developing vaccines to induce this phenotype could enhance human immunodeficiency virus control strategies. People living with HIV face age-related diseases despite antiretroviral therapy. A geroscience-guided approach targets CD38 overactivation, nicotinamide adenine dinucleotide depletion, and indoleamine 2,3 dioxygenase 1 dysregulation. Nicotinamide adenine dinucleotide supplementation with nicotinamide mononucleotide and niacin restores oxidative phosphorylation and DNA repair. Flavonoids like apigenin inhibit CD38. Urolithin A and methylene blue enhance mitochondria. Resveratrol activates sirtuins, reducing inflammation and aging in people living with HIV. Pharmacological CD38 inhibition is a targeted approach, showing promise in increasing NAD+ levels. Senolytic agents like dasatinib and quercetin, and xenomorphic agents such as metformin target cellular senescence, modulating the kynurenine pathway and restoring gut eubiosis through microbiome interventions can reduce mitochondrial toxicity and immune activation in people living with HIV. The study proposes a novel hypothesis linking CD38 overactivation, nicotinamide adenine dinucleotide depletion, and mitochondrial dysfunction to immunological failure. It integrates immunology, metabolism, and geroscience, offering actionable targets for early-phase trials. However, the hypothesis is hypothetical, with limited direct evidence and complex mechanisms requiring rigorous validation and may only apply to specific patient subsets. The proposed research framework addresses immunological non-responders through a phased approach. Phase 1 involves pilot studies with nicotinamide adenine dinucleotide supplementation and cluster of differentiation 38 inhibition. Phase 2 focuses on mechanistic validation. Phase 3 includes randomized trials for cluster of differentiation 38 inhibition and mitochondrial enhancement. Phase 4 integrates geroscience strategies targeting long-term outcomes like frailty and survival. Cluster of differentiation 38 overactivation is a key driver of immunological failure in virologically suppressed people living with HIV. Reducing immune activation is crucial for cluster of differentiation 4+ recovery. Nicotinamide adenine dinucleotide depletion links chronic inflammation and accelerated aging. Early antiretroviral therapy initiation is vital to prevent irreversible damage. A multi-target approach beyond antiretroviral therapy is needed, but requires rigorous validation through mechanistic studies and randomized controlled trials.